activities. So that's science, technology, engineering, arts, and mathematics activities that you can do at home. Today, we're focusing on the E in STEAM, which stands for engineering. We're doing natural disaster resistant structures. In case you didn't notice, it is pretty windy out there. And those are the types of things that we need to consider when we're building natural disaster resistant structures. But before we get started on that, there's a few things we need to clear up. Like, what is a natural disaster? How is it different and how is it the same as regular weather or the climate? Let's check that out. Let's start with the weather. I bet you can name all different kinds of weather, like hot and sunny, windy and cold, snowy and rain, or maybe even just mild temperatures. And temperature definitely is a defining characteristic of weather, but more accurately, weather is the condition of the air or the atmosphere of our planet, and it is constantly changing. It can be different day to day, hour to hour, or even minute to minute. And weather is determined and defined by more than just temperature. It can be defined by its humidity, by the wind speed, wind direction, and lots of other things too. It can be light and regular weather, like a light rain, or maybe a little bit of snow, or it can be severe weather, like blizzards, hail, and thunderstorms. Now that we've talked about weather and how it's constantly changing, let's talk about climate. Climate is weather, but over a long period of time. It's the average weather or long-term pattern of weather over a period of at least 30 years. There are many different types of climates, and they vary from place to place and region to region. But there are 5 main kinds globally. We have polar, continental, mild, dry, and tropical climates on planet Earth. In Ontario and the rest of Canada, we have what's called a continental climate. And that means that we have long, cold, snowy winters and a shorter, mild or warm summer that has a shorter growing season. We're a transitional zone between mild climates and polar climates. If you start to travel south through North America, down into the United States, you're going to start to experience what's called a mild climate. A mild climate generally has a more rainy winter instead of a snowy winter, and they have a warm summer. If you head north into the North Pole and the Arctic, you're going to get a polar climate, which takes place on the poles of the Earth, so in both the Arctic and Antarctic. They are almost always freezing cold, but some polar climates are what are called tundra climates, which means that they do have a short warm season when plants can grow. That leaves us with dry and tropical climates to discuss. Dry climates, you guessed it, are places like deserts and grasslands. They get very little precipitation or rain, and they are some of the hottest places on Earth. Tropical climates are places that are typically pretty wet. There's 3 different kinds. One is characterized by rainforests. The second is characterized by long, rainy and windy seasons called monsoons. The third is characterized by having 3 distinct seasons instead of our 4 seasons. For more information about the distinct climate regions all around the world and Canada's distinct climate regions, check out the description of this video where I've posted a couple of links that are going to give you a lot of fun facts. Now that we've talked about climate and weather, let's talk about natural disasters. Natural disasters can be caused by weather and climate or not, and they are completely outside of humans' control. They're caused by the forces of nature, and they can put human lives in danger. There's a lot of different natural disasters. Take a couple seconds and see if you can name a few. natural disasters? I bet you were. Did you think of avalanches? An avalanche is basically a giant mass of snow, ice, and rock debris that comes tumbling down a mountainside and can bury anyone trapped in its path. Take a look at this footage. That avalanche was pretty cool. But you know what's not cool? Droughts. Droughts are really hot, and they're characterized by little to no precipitation or rainfall. So what happens is there's a huge water shortage, which can be very dangerous for humans and their livestock because there just isn't enough water to go around. Take a look at these pictures. Just looking at that made me thirsty. Let's talk about floods. Floods are basically the opposite of droughts. Floods happen when there's too much water and the water rises and overflows from where it would naturally be. Check out these floods. Now that we've seen a flood, let's talk about earthquakes. Earthquakes are a sudden and severe shaking of the ground, and they're caused by movements in the Earth's crust. Want to see? Wow, that earthquake really shook things up. Next, let's talk about a tsunami. Tsunamis are giant walls or waves of water that rise up out of the ocean, and they're caused by an earthquake that happened in the ocean. Think of it like walking around with a cup of water. Every time you take a step, the water sloshes in there. Every time there's movement of the cup, the water sloshes around and it might rise up so high that it spills over the edge. With a tsunami, the cup and the water is the ocean. The movement, the earthquake, is you moving the cup. Take a look at this footage. Whoa, that tsunami was pretty freaky. But you know what else is freaky? Tornadoes. Tornadoes are a giant vortex of spinning wind. They're giant cloud funnels that come out of a big storm cloud, and they form over land. The wind can get up to really, really fast speeds and blow things away, including houses. Take a look at this. Similar to tornadoes are hurricanes. The only difference between a tornado and a hurricane is that a hurricane forms over water, while tornadoes, as we know, form over land. And hurricanes don't happen quite as often as tornadoes do. Check them out. Now that we've got tornadoes and hurricanes down, let's look at volcanic eruptions. Volcanoes are basically big hills that have a crater or a vent or a hole in the middle of them. And when they erupt, lava and gas and vapor and rocks come spilling out or even exploding out, just like this. That was pretty toasty. But you know what else is toasty? Wildfires. Wildfires are the last kind of natural disaster that we're going to talk about today. Wildfires take up huge portions of land and spread very quickly through the natural environment. They're much, much bigger than the small campfires that we roast marshmallows on. And they can come into cities and towns and cause real damage if they're not contained. But that's why we have firefighters. Check out these wildfires. Weather, climate, natural disasters, they're all out of the control of us humans. But they are all interconnected in some way. But they're all very unique and special and different from each other. Weather is the day-to-day, climate is weather over a long period of time, and some natural disasters, not all, are caused by weather and climate. That leads me to today's activity. We may not be able to control the climate, the weather, or natural disasters, but there are definitely things we can do to protect ourselves from them. Figuring out exactly how is what engineers do best. Speaking specifically about natural disasters, engineers build instruments and collect data that can help predict when a natural disaster is going to happen and reduce their negative impacts. They build things to keep us safe from natural disasters. So this includes mountain, ocean, earth, and atmospheric monitoring systems, weather instruments, satellites, and radar, and so much more. They also work to build stronger and more resistant structures that will stand up to natural disasters and keep us safe. That's what we're going to be doing today. Today, I challenge you to build a structure that can withstand a tornado, an earthquake, and a flood using the engineering design process. Here's what you're going to need. First, you'll need paper and pencil for brainstorming and planning. Next, you're going to need materials to build your structure. I'm going to use Lego, but you could use marshmallows and popsicle sticks, you could use recycled materials, craft supplies, or anything else you have at your house that will work for this project. Next, you're going to need a fan or a blow dryer to simulate a tornado. Next, you'll need a tub or a big water basin or a sink that you can use to simulate a flood. Finally, you're going to need a table that you can shake, a tray that you can shake, even a pillow that you can sit your structure on and move it around to simulate an earthquake. Got everything you need? Awesome. Let's start with step number 1. Ask and define. In step number 1, we're gonna ask and define exactly what it is we need to do. So our goal, your goal, is to build a structure that will withstand an earthquake, a tornado, and a flood. Step number 2, brainstorm and imagine. For step number 2, I want you to take the next 30 seconds to shout out, write down, brainstorm all of the ideas you can think of for what your structure is actually going to look like. What will a structure look like and what will it have to help it withstand an earthquake, a flood, and a tornado? Are you ready? Go! During my brainstorm, I came up with 3 main ideas. First, I thought that my structure should be elevated or lifted off the ground so that the water could sweep underneath of it during the flood. Second, I thought that my structure should be made up of strong and stable shapes so that it can withstand the earthquake. Third, I thought that the roof of my structure should have curves so that the wind from the tornado will easily flow over top of my structure without knocking it down. What did you come up with for your structure? Step number 3, plan. During step number 3, it's time to actually plan. We're going to plan what our structure will actually look like. We'll use all of the ideas that we came up with during the brainstorm and put them into practice. So I'm going to draw the first drawing of what my structure looks like in my head. Now it's time to draw my structure. You can see that it's made out of the strong and stable shape of a triangle. It has a curve on the roof or a slant to allow the wind to go over top, and it's elevated on stilts. Step number 4, my favorite, build and test. During the build and test stage, I'm actually going to build my drawing. I'm going to bring it to life, and then I'm going to test it against an earthquake, a tornado, and a flood. Now it's time to build. Structure is complete. It's up on stilts. It has a nice curve so the wind can easily flow over it. And it's got strong and stable shapes. It has a triangle base and a pyramid on top. Now that I've built my structure, let's test it out. Test number 1, tornado. Too bad. Test number 2, earthquake. Test number 3, a flood. Step number 5, reflect and improve. Now that I've tested my structure and it's been through a flood, a tornado, and an earthquake, I can think about things that went right and things that went wrong, things that I'll keep and things that I'll improve upon. So let's start with the things that went right. I would say that the stilts on my structure really worked to keep it elevated during the flood. The top portion of my structure, where the people would live inside, stayed dry and safe during the flood. Things that I would improve upon for next time, things that went a little wrong. I think that I would secure my structure to the ground. I would provide it with a foundation that keeps it in place, because during both the earthquake and the tornado, my structure shifted around, which you wouldn't want if there was people living inside. In what ways did your structure work, and in what ways can you improve it? Let me know in the comments. Well, thinkers and tinkers, you did it! You finished another awesome STEAM activity. Great job! You planned and imagined and brainstormed. You built and you tested it, and then you reflected and improved. Great work. So what now? Now, I would love to hear from you. Post a photo, leave a comment, or upload your own video. Let me know what your structure looked like, how it was successful, how it was unsuccessful, what went wrong, what went right. But for now, I guess I'll just say thanks for watching, and I'll see you next Tuesday and Thursday at 2 p.m. with more fun STEAM activities. Thanks guys, and I'll see you next time.